Yeah. So maybe today we will solve from a collection, from different topics. Maybe we will do one problem from recurrences, some 1-2 problems from arithmetic progressions, and from recurrence solving, then maybe some word problems in which one can apply recurrences, and maybe 1 algebra questions. It will be a mixed bag of things. Okay, let us see. Maybe to begin with, we will do a recurrence, solving some recurrence. Okay, so solving. It's in general, I'm saying recurrences. Okay. So in this, let me say what we have already done, and then I will. There are 1 or 2 questions I had given, which we will try to solve. So we have already done the following. That if you have a recurrence like this, where you have an and it is connected with the previous terms in, let's say, this manner. Okay, right. Then what is the step 1? Just is you look at the quadratic. You look at this ax square plus bx plus c, and you look at its roots. Then the solution is lambda 1 alpha to the n plus lambda 2 beta to the n. Now lambda 1 and lambda 2 will be determined by some initial conditions. Okay, lambda 1, lambda 2 to be determined by initial conditions. This was our staple, right? This was our very important equation. Now in connect, and we have seen examples, so I'm not going into this again. But in this, I had given some problems. I think Aparna, I think you were there in that class. So could you recall me in related to this? I had given some problems. Or
Sir, I think it was something like an minus 4 an minus 1 plus 4 an minus 2 equals to 0, and
an
a1
minus, sorry,
an minus 1
plus an minus 1 or 2 an minus,
sir, an minus 4 an minus 1 plus 4 an minus 2 equals to 0, and a1 equals to a2 equals to 1.
right. So even if you have forgotten this, it will probably not be very useful for this. Let's try. Let us see. So for those who have seen this question, anything that you have tried, I don't know, Ishana, were you also there in that class? If you have tried something?
Sir, I don't think I was there.
You were not there. Okay, no problem. Yeah. So what is A3?
Zero.
Right, it is 0. Right. So what should the solution be for this kind of question? Any ideas? Aparna, do you have any ideas? All right.
No, sir.
So the characteristic polynomial, which is this quadratic, right, which is associated, what are the roots of this?
Two.
2, right? So then what is the problem? Where is the problem in applying this formula? Hmm? My question is, where is the, you must, if you're getting stuck, then where is it that you're getting stuck? Where do you see that this method is insufficient? Mm-hmm. No ideas. Okay, then I will have to ask a different question. Okay, let me ask a different question on this board only, because I need to be sure about something. So this is a different question. Okay. Let's try this. Again, the question is same, solve. You can take a1 equal to a2 equal to, anyone?
Sir, an would be equal to lambda 1 3 to the power n plus lambda 2 2 to the power n.
Yes. Yeah, so that's a good first step. Yeah. Is everybody okay with this? These are the roots, right? Even if you don't remember the proof, we did this in different ways, right? But even if you just follow the method, alpha and beta are the roots. So you find the roots, and then this is a general solution, right? This is how you can think of it. This is how the answer will look like if I don't know anything else. If I don't know the initial values, or if I don't know some other values, right? I need to know some values to completely know the sequence, right? How the sequence starts, I need to know for, let's say. But so what will lambda 1 and lambda 2 be? Because we know the initial values. Sorry, 1 and minus 1 or something like that.
Minus 1.
1 and minus 1. Okay, your voice was not very clear. So anyways, I think this, let's just check if it, no, it does not work, right? This does not work. Yeah, just solve it. Yeah, Nagesh, you said the answer. Hey, these things you guys should solve faster. I mean, okay, these are just, right? Put n equal to 1 and then put n equal to 2. Please solve it and tell me. So put n equal to 2, right? You will get the linear equations.
I think lambda 1 is 0 and lambda 2 is half, minus half.
Minus half, I am not, half is,
Oh, sorry, I think it's wrong.
no.
Lambda 2 is 1 and lambda 1 is minus 1/3.
Minus 1/3.
Yes.
Okay, thank you. Okay. So because both the equations have to be satisfied, you can't be like me and just say that this is the 1 and this is, or whatever I said something wrong in the beginning, right? Because it works for n equal to 1, but it has to work for both. So okay, let's say that is correct. Okay. So, is it now okay with everyone? Pragadesh is here, and who else has not spoken? Yeah, others? I hope, otherwise you tell me, because that's why I did this example. Okay. just following the steps. So you have to just put n equal to 1, right? And then it put n equal to 2. This lambda 1, lambda 2 is your x and y, which you have while solving. Right? And then you just solve. Okay? I believe you will get that. Okay, so this is fine. So you see the differences. Now, can anybody tell the difference between that problem and this problem? Yeah. Here, what is happening? Here, this quadratic has a unique root. Right? This quadratic has only one solution, and that is where the problem is. Right? But fine, this has one solution. Then my question is, can you at least say some solution? Can you maybe let me use the word guess? Guess a solution. Like you may even just forget this for a minute. You don't have to answer perfectly, but just can you at least guess one solution? And this guessing idea I had kind of said last time when we were doing this. X equal to 2, right? So shouldn't you guess 2 to the power n? 2 to the power n is certainly not a bad guess. I mean, 2 to the power n should be involved in the solution. Right? So this is one solution. So if 2 to the power n is a solution, that means that any lambda times 2 to the power n will also be a solution. Isn't that right? I mean, if an satisfies this equation, then lambda times an will also obviously satisfy this. So you can just cancel the lambda. Remember, no other conditions are, if no other conditions are given, then if you have a solution, any constant multiple of that will also be a solution. If no conditions are given, when the conditions are imposed, then the restrictions come. But it's a general feature, and this is a very, very important thing, right? That if you have a solution, then any multiple of that will also be a solution. Okay. So this way you can guess one solution. But the problem is that that will not work. Will it work? If I say that you take lambda times 2 to the power n, can you find the lambda? Is there a lambda? Can you find the lambda using the initial conditions?
It will have two values, right?
Yes. Yeah. And that's why that, so it's not possible. Yes. Right? That is the problem. So because when you put, let's try to follow on that two values, maybe that can throw us some insight. Because if this is to be 1, and then this also has to be 1. I mean 4 times lambda. So this is some problem. This is not to work. Right? So what do we do? I don't know. I don't know. What should we do then? This should have some solution. It's not just a random thing, right? Please try find some other values. Try to see a pattern. Find A3, A4, A5, find till A10. As when we were kids, we used to do this. Or means when we are learning any topic. Today I was learning some topic and I was solving, filled pages and pages of some, whatever topic you are starting to do, right? You have to solve. Like I'll show you. I mean, usually I don't do all this, but I don't know if you can see. I probably can't see. So it looks like some matrices, some theory we are learning, and we are just continuously solving hours and hours to get used to that thing. Obviously, not in a mindless way, whatever. You have to also do it. So find A4, A5, A6, A7, A10. Then only you can tell something, right? Where is the important page? I was solving something now, so I can tell you guys that is gone. Anyways, no problem. Let's list down the values. What is the next one?
-4.
Sorry, did you say -4? I think
-4. -4.
-4, right? Yeah.
-16. 68.
I think the numbers are getting big, right? That is a problem.
208.
208. Okay. So do we see anything? Probably no, right? Yeah, not maybe very useful. So then what should we do? Well, you already know that, so lambda equal to half is kind of is a candidate, right? So if lambda is equal to half is a candidate, then your solution here, one kind of solution, would look like 2 to the n minus 1. So why don't we subtract this from these terms? Because this solution will be like, lambda times 2 to the n plus, some other lambda 2 times something, which we don't know. Right, it's a recurrence relation after all, right? We know that if there were two roots, the solution would be like that. Okay, so we subtract one of the solutions. Maybe it will tell us some pattern for the other solution. I don't know, right? We will have to do it and see. So let us subtract 2 to the n minus 1. Okay, so 2 to the n minus 1 means 2 to the 0. So I subtract 1. And from here I will subtract 2 to the 2 minus 1. So that's -2. And I'll write the difference here. I just write terms. This may look like a very what is going on? It's a strange thing going on. But yes, because we are trying to find some way. -16, -64. You see what I'm doing, right? I am taking away one solution because it's a combination of two solutions, kind of. Taking away one solution, and maybe that will reveal some pattern. Maybe you're getting 0, -1. Yeah. I mean, sorry, if you just add it, right? 0. No, so it was correct. -4. I think I'm writing too small. -12. 0. 4. How much is this? 80? 8 here. Right? Yeah, if you have calculated more, then so as we have this. Now, is this something that you recognize? So this is like power of 2 here, and this is like power of 2 and then 3, and this, and then this is like 4 to the 5. Any more terms you have calculated? So far, nothing seems to be there. It's a long process. Yeah, one has to do it. Anyways, so given you do my point is that if you do the work, if you put in the work, like you calculate more terms, okay, few more terms, you write them, you will see some pattern in this. Okay, you will see some pattern. Like because I've done it, so I know it. But if when you do it, you will know it also. And if you don't see, then you have to take this route and do the same process. It's a long process, but put in the work, right? Then you will see some pattern. In one of those two branches, you will see some pattern. Okay. We will not do it now, otherwise we will not able to do anything else today. But try to give it a try. Okay. So try to see some pattern. Let's just say, try to find a pattern. Or if you have already, while I'm saying all this not very useful things, I think if you have already found a pattern, it's better. Okay. But don't worry, once you find a pattern, you'll actually find a theorem which you can apply to these situations always. Okay, so there's a lot more you'll get. So try. The pattern will be something, maybe it will be something like, n times 2 to the n. Something like that. Yeah. Plus there will be some constant multiple also, some lambda. So all that will be clear when you calculate enough terms. Right? Okay. So then let's not get more into it maybe. Otherwise will not end. But you have to give it a try. Okay. I've told you the way. Now you have to. Yeah, let's do one exercise which is more straightforward. Okay. Check that alpha to the n and n times alpha to the n are solutions. This n times alpha to the n you would see through in that simple case through patterns, but there is also a derivative reason. But in leaving all that aside, try this. This is just you have to put and show that it's indeed satisfying. There's nothing profound about this. And when you do differential equations, you will see the same thing repeating again. Okay. Just there will be x in place of n. Uh, yes,
Sir, I think it works.
it works, right? Have anybody? I mean, let's do the second one. I mean, so it's basically that's how the equation is made, right? It has to satisfy. So an minus 1 would be what? N minus 1 you have to just put in place of n. And there is just like, if you just expand and see that everything cancels. Right? The alpha to the n cancels if alpha is not 0. If it's 0, that's a very simple case. This is 0, you can see, right? So there is nothing to do, but these two are solutions. If we know that these two are solutions, then any combination will also be a solution, right? This we have said last time. And you can check, I mean, if alpha to the n is a solution, if a n is a solution, bn is a solution, then an plus bn will also be a solution. It's a, and therefore the general solution will look like this. So in place of beta to the n, so when the meeting ends, just join, it will be this. And now you can again find lambda 1, lambda 2 using the initial conditions. Here the twist is the n comes here. Okay, that is the twist. All right, so have a look at it and we will meet on the other side. Just maybe 2 minutes, I will come. Okay? So you just join and then wait if I don't get it.